So the equation of the axis of symmetry of the graph of a quadratic function is x equals 3. And the graph passes through the points -1, -6, and 5, 0. And we have to come up with an equation of this graph. So the first thing, this is a problem-solving kind of question. First thing I'm going to do is I'm going to just write down everything that they told me on my graph. I know that my axis of symmetry, so I'll take out my red pen. I know that that's at x equals 3. And I know my graph goes through the point 5, 0. And it also goes through the point -1, 6. -1, -6, sorry, there we go. And there's some parabola that goes through those points, and I need to find its equation. So what do I know about the equations of parabolas? Well, they have an a value, a p value, and a q value, and I need to find each of these numbers. Now they did tell us one of the numbers. So based on what we've drawn, you either know a, p, or q already. Which one do you know? You know p. Because the axis of symmetry would go through the vertex, and it's always the same. So we know p is equal to 3. So we now have the following. We just need to find out what a and q are. And this is where our systems of equations chapter from grade 10 comes into play. When there are two things you don't know, we don't know a and we don't know q, how many equations do you need to solve it? You need 2 equations. And that's where the points come in. So remember in the previous question I said if a point is on the parabola, it makes the equation true. If a point is not on the parabola, it doesn't make it true. So I can create equation 1 by plugging in. I know that I have the point -1, -6, so that means when y is -6, x has to be -1. That creates an equation with a and q. In fact, I can simplify that equation a little bit. -1 minus 3 is -4, and -4 squared would be 16. So simplified, I have the equation -6 equals 16a plus q. I can do the same thing with my other point and get a second equation, because I know that when y is 0, x is 5. And if I simplify this one, I get 4a plus q. If you have a system of equations, if you have 2 things you don't know, but you have 2 equations with those 2 things you don't know, you can solve for them. And we had sort of 2 main techniques that you used algebraically, either the substitution technique or the elimination technique. So you could choose either one, what you would like. I find most students go and like the substitution technique in this case because is there a variable that's really easy to get by itself? Yeah, like, can you see you can get q all by itself? All I'd have to do is move the 4a over. So then I would have minus 4a is equal to q. Once you've got q all by itself in one equation, you can substitute it into the other equation. So I'm going to take equation 1, which was -6 equals 16a. But then instead of writing q, what could I write instead?
-4a.
I could write -4a. And now I have an equation with just a. So now I can solve a. Those are like terms. That would be 12a. I can divide both sides by 12. Negative 6 over 12 reduces nicely to negative 1/2. Once you have a, you could either use equation 1 or equation 2 and find q. So that's what I'm going to do next. I'm going to find q. I would probably use that negative 4 times a is equal to q. Right? That's just taking this equation here and plugging in my a value. And half of 4 is 2, and negative times negative is positive, so I get 2 is equal to q. And now I have everything for my solution. I needed to find my a value, which I did, negative 1/2. I needed to find my p value, which I found right away to be 3. And finally, my q value is plus 2. Double check. I'm going to go to my graph. I just want to double check if this actually works. Here, I'll zoom out so you can see everything. Wow, that's really small. But if I went to my graph, according to this, my vertex should be at, I'll go, everything I'm adding now, I'll put it in purple. That's my vertex. Then I should be able to go over 1, down 1/2, over 1, down 3/2, and sure enough, that matches up with that point. So I could sort of use it as a double check. Does my a value and my vertex actually do what I want it to do? This would be the parabola as a result of what we found. So there's going to be one like this on your quiz on Friday with systems of equations. So you needed to find a, p, and q. The axis of symmetry gave us the p right away. Then, because we know the points, we can plug them in, and that would give us 2 equations. Then you can either use substitution or elimination to solve. Question for practice. You can circle number 9.